Today we're going to talk about arithmetic sequences and series. By the end of this video, you should be able to identify and write equations for arithmetic sequences, and you should be able to find the sum of an arithmetic series. First, let's talk about some definitions and some symbols. First, we need to talk about an arithmetic sequence. So an arithmetic sequence is a sequence or a pattern of numbers where you add a constant to find the next term in the sequence. So for example, you could add 2 every time to get to the next number in the sequence. You could also add a negative number. You could add -5, which would end up looking like subtracting. And we call this constant the common difference. So let's look at some symbols. First, we have the Greek letter sigma. And this refers to a sum. So we'll talk more about this notation later, but it means that you are adding a list of numbers or adding the terms of a sequence together, which we call a series. A sub n refers to the nth term in a sequence. It's very similar to f of x in function notation. S sub n is the sum of n terms. D is the common difference. That is the number that's being added to find the next term in the sequence. This is very similar to slope when we talk about linear functions in Algebra 1. A1 is the first term. So it's similar to the y-intercept. Again, when we're referring to linear functions. And n is the number of terms. For example, if I ask you to find a sub 5, that is the fifth term, then you would plug 5 in for n in the formula. So this is just like x in our linear equations. So we have 4 examples here. We want to figure out if they are arithmetic or not. So we need to look at what is being added or subtracted to each term to find the next term in the sequence. So from 4 to 7, we're adding 3. 7 to 10, we are adding 3. 10 to 13, adding 3. And 13 to 16, adding 3. So this is arithmetic. And in this case, D is 3. For the second example, to get from 3 to 6, you add 3. 6 to 12, you add 6. Add 12, add 24. This is not arithmetic. For the next one, from 22 to get to 17, you subtract 5, subtract 5, subtract 5, subtract 5. So this is arithmetic, and D is -5. And the last example here, we add 1, add 2, add 3, add 4. We're not adding a constant, so this is not arithmetic either. So here we have the formula for an arithmetic sequence. And this is the same formula that is on your SOL formula sheet. So if you take your SOL formula sheet and scroll down to the bottom, that's where the sequences and series formulas are. It tells you what A, N, S, N, S sub infinity, R, and D represent. And then it has formulas for arithmetic and formulas for geometric. We'll get to geometric in the next set of notes, but today we're just focusing on arithmetic. So the first one is our formula to find the nth term. So this is very similar to y equals mx plus b in Algebra 1. It's the important formula that tells you the rule that you are following to find a term in the sequence. The second formula here is the recursive formula. We won't spend too much time on that. It's just a different way of defining it. And the third and fourth formulas are some formulas that we'll get to in a few minutes. So in our formula, a sub n is the nth term. It's very similar to f of x. Then a sub 1 is the first term, d is the difference, and n is like x. So we will always have n in our formulas. But if we're evaluating, then we might plug a number in for n. So in example number 5, we are given d and a sub 1. We just want to write the rule for the nth term. Whenever you see anything that says find the nth term or write the rule, that just means write the formula. So this will be a sub n equals 2 minus 2 times n minus 1. And that's all we have to do. We're just plugging numbers in for a sub 1 and d. Number 6, we're asked to write the rule for the nth term, which again means write the formula, except we're given a sequence. We're given a list of numbers. We need to figure out a sub 1 and d from this list. So a sub 1 is easy. That's just the first term. And d is whatever is added to get from one term to the next. So if you look at the pattern, we are adding 4. So that means d will be 4. So if we write out our equation for the nth term, we have a sub n equals a sub 1 plus d times n minus 1. So that is the rule for the nth term. Then it also asks us to find a sub 15. So this means we are looking for the 15th term. We could do this by just continuing to add 4 until we have a list of 15 terms in our sequence, or we could use the formula. So if we use the formula, we plug 15 in for n, and then you can just type this in your calculator. 19 plus 4 times 15 minus 1. And that's 75. So the 15th term in this sequence is 75. The next problem asks us to write the rule for the nth term given two terms. So again, we are writing the rule, we're writing the formula, except we're just given two terms. There are several ways that you can figure out the two important pieces of information, which are the first term and the difference. But you definitely need to figure out the difference first. So you can use the slope formula because we said the difference is like the slope. You can write out a bunch of blanks and put 18 in the fourth blank and 48 in the 10th blank and try to figure out what you need to add to fill in all the numbers in the middle. I think that using the slope formula is the easiest. So in Algebra 1, it was m equals y2 minus y1 over x2 minus x1. So for this example, a sub 4 equals 18 is kind of like writing 4, 18, and a sub 10 equals 48 is like the point 10, 48. So we can just use these two essentially coordinate points with our slope formula to figure out what D is. So if we have 48 minus 18 over 10 minus 4, that'll give us D. So we have 30 over 6, which is 5. Now, to find the first term, we can either use the formula, plug in a point and D and try to solve for A1, or we can say, well, this is A1, this is A sub 2, A sub 3, A sub 4. We know A sub 4 is 18. We know that the difference is 5. So since we are going backwards in the sequence, instead of adding 5, we're going to subtract 5. And we end up with A1 being 3. So then we can just write the rule. Just A sub n equals A sub 1 plus D times n minus 1. Number 8 says, determine which term is 57 in the sequence. So we are looking for n. 57 is our a sub n. We want to find n. So again, we're given a sequence, and we need to look at that and figure out what a1 and d are. So a sub 1 is negative 59, and d, if you look at the pattern, we're adding 4, so d is 4. So we're going to use the formula. We have a sub n equals a sub 1 plus d times n minus 1. We want to plug 57 in for a sub n, negative 59 in for a sub 1, 4 in for d, and we want to solve for n. So first we need to add 59 to both sides. So that gives us 116. Then we can divide both sides by 4, which gives us 29 equals n minus 1. So n equals 30. You could also do this by continually adding 4 until you get to 57, but clearly that's going to take a while, so that's probably not the best method. Now let's go on to series. A series is when you add up several terms in a sequence. So we have a couple different formulas on our formula sheets. We have S sub n, which is the sum of n terms, equals n over 2 times a sub 1 plus a sub n, which can also be written the way that it's written here on the notes. It's just a different way of writing the same formula. And then we also have this other formula. S sub n equals n over 2 times 2 a sub 1 plus n minus 1 times d. It just depends what information you're given in the problem, which formula you should use. So number 9 asks us to find the sum of this arithmetic sequence. We're given a list of numbers and we're told we want to add up the first 19 terms. That's what n equals 19 means. So we can look at this sequence here. We know that the first term is 2, and we can tell that we are adding 1. So if we have a sub 1, d, and n, then we should probably use this second formula given here on the formula sheet. We could use the first formula, but that would mean we'd have to find a sub n, which is the 19th term. So just using the second formula will be a lot faster. So we have that the sum of the first 19 terms equals n over 2 times 2 a sub 1 plus n minus 1 times d. And then we can just type it in the calculator. Use the fraction button. 19 over 2. And even though the formula sheet uses the square brackets, you can just use parentheses. And this gives us 209. So this means that if we added up the first 19 terms in this sequence, we would end up with 209. Obviously, you can write them all out and add them all up if you need to, but the formula is a lot faster. Now, we get to this part with sigma notation. We already said that this is the Greek letter sigma. And what this means is that we are starting with the first term, and we are going until the 25th term. So we would want to plug 1 into this formula, figure out what that is, then plug 2 in all the way up to 25, and then add those 25 numbers together. But instead of doing that, we can either use the formula or we can use the calculator. So this formula here on the notes says that you want to use the first term and the nth term. So if I plug 1 in for n, I get 4 times 1 is 4, plus 1 is 5. So the first term is 5. Then I can find the 25th term, which is the nth term. 4 times 25 is 100, plus 1 is 101. And I'm adding up 25 terms, so n is going to be 25. So I can say that the sum of the first 25 terms is 25 times 5 plus 101 over 2. And then I can type it in the calculator. That ended up with 1,325. But there is also a sigma function on the calculator. If you go to math and you scroll down to summation, you can see there's a sigma there. It brings up this sigma for you to type in, and you just fill it out the way it's written on the problem. So we have x equals 1, and then there's a 25 on top of the sigma, and then we have 4x plus 1 in the parenthesis. When you click enter, it verifies that we got the same answer that we did with the formula. So we have another sigma problem for number 11. So you go to math, summation, and this problem uses n, you can use x, it doesn't really matter what variable you type in, as long as it matches the one that you put in the formula in the parentheses. Oops. This gives us 486. If we were going to do this by hand, we would first want to plug 3 in for n. So we'd get 15 minus 2 is 13. Then we'd plug in 14 for n. 5 times 14 is 70, minus 2 is 68. And here's where it gets tricky. N is the number of terms you are adding up. So here we're starting with the third term and going to the 14th term. So we're skipping the first term and the second term, so we're really only adding 12 terms. If we use the formula, we end up with n is 12. We have 13 plus 68 over 2. So if you type that in your calculator, you end up with 486, which is the same answer we got using the summation function. That's it for arithmetic sequences.